everybody, welcome back to another video. So in this video we are going to discuss 14 most frequently asked questions in Python interviews. So this video is going to be very helpful to you all. So let's begin with the questions. So the first question is, what are the key features of Python? So here I have written few key features of Python. So you can remember 4 to 5 of these. So if you answer just 4 to 5 of these, that's enough for the interviews. So the second question is, what is PEP8? So PEP stands for Python Enterprise Proposal. So it is a document that provides various guidelines to write the readables in Python. So whenever you're declaring a variable or function name, so there are certain things which you should keep in mind so that the code is readable. Obviously, writing the code, writing the logic is important, but writing it neatly, cleanly, so that the other person who is reading your code or someone who is reading your code years later can understand it. So you should follow some guidelines. So for that we have Python Enterprise Proposal. So PEP describes how the developer can write beautiful code. The aim of PEP is to enhance the readability and consistency of code. The third question is, what are access modifiers in Python? So Python uses underscore symbol to determine the access control for a specific data member or a member function of a class. So there are 3 access modifiers basically in Python: public, protected and private. So for public you do not need to mention anything, but for protected, one underscore is used to declare that it's a protected access modifier, and for private access modifier we use 2 underscores. So access specifiers or modifiers in Python have an important role to play in securing data from unauthorized access and in preventing it from being exploited. So whenever you're declaring a variable in a class or function, you can use these access modifiers. So for example, if you want to declare a variable as protected, you can write underscore var1 equal to 22. So this way you're declaring it as a protective variable, data member. So public can be accessed from anywhere. So a public variable can be accessed from anywhere. But if you have declared a variable as protected, so derived classes, so derived classes can access it. So in case of inheritance, when a class is deriving it, so protected data members can be accessed when it's declared as protected. But when it is declared as private, derived classes cannot access it. Only that particular class can access those variables. The derived classes cannot access those data members. So this is the difference between public, protected and private access modifiers. So the next question is, what are data types in Python? So there are 5 data types in Python. So the first one is numeric, second is sequence type, third is boolean, fourth is set, fifth is dictionary. So let's discuss a little bit about each. So the first is numeric. So in numeric we have int, float and complex number. So int is basically 5, 10, 15 or any such number will come under int, and when you put a decimal point 5.0, 5.2, 100.2, that will come under float, and complex number is declared like 5 plus 4j. So like that you can declare complex number. So this is your numeric data type. Then the next is sequence type. So in sequence type we have 3 subtypes: string, list and tuple. So string we all know, it's a combination of characters. So a is equal to in inverted commas we are hello world, that is a string. And in list we declare with square brackets. So if we write b is equal to, in square brackets, if we write Python, Java, C like this, so we are declaring a list over here. So that is list. And then tuple, and tuple is declared with round brackets. So again, similarly, if you write b is equal to, and in brackets we write Python, Java, and inverted commas, that is tuple. So the difference between list and tuple is that list is mutable, you can change values in it, but in tuple you cannot. And there are few other differences also which we will cover at the end of this PPT. So there is a question related to this as well, so wait for it. And yeah, so the third data type is boolean. So boolean we all know, true and false. And the fourth data type is set. So set is an unordered collection. Sets are iterable, mutable and has unique elements. Order of sets is undefined. So if we write b is equal to, and in brackets if we write 1, 2, 3, 3, 4, this if you're declaring this as set, if we are declaring this as set, so and in set we write like this, set and bracket b. So basically we are declaring this as set, and in set will always have unique values. So the output will be 1, 2, 3 and 4. So you cannot repeat an element inside a set. So set will always have unique elements, and it is iterable, and you can change values in it. And dictionary is an unordered data type in Python. So and it stores key value pairs. So you can declare it like this, a, and in curly brackets. So dictionary is declared with curly brackets. So name is your key, manva is your value, marks is your key, 85 is your value, and like this you can print values. So this is dictionary. Dictionary is key, stores key value pairs. Okay. Now the next question is, what is Python path? So Python path is an environment variable which you can set to add additional directories where Python will look for modules and packages. Next question is, what is docstring? So docstring is basically documentation strings. So Python documentation strings provide a convenient way of associating documentation with Python modules, function classes and methods. So whenever you're declaring a function and you want to write what that function does, so we can write it in docstring. So documentation string. Now you will ask me, what is the difference between a docstring and a comment, because you can also write the same thing in comment, but in comments are not they are not accessible in runtime, but docstring is accessible in runtime. So you can access it like this. So see, I've written over here, we can access these docstrings using the underscore underscore doc underscore underscore attribute. So if you write so this is how you will declare a docstring. So docstring is always declared with 3 inverted commas. You can single inverted commas is also fine, double inverted commas is also fine. So this is the function def fun underscore s n, and this is returning this value, that's okay, but this is a docstring. So docstring will always be written with 3 inverted commas, and docstring will describe what the function does. So it's specified in source code to document a specific segment of code. Unlike conventional source code comments, the docstring should describe what the function does, not how. So the comments will describe how the function is done, but in docstring you will describe what is this function all about, and you can access it with underscore underscore doc underscore underscore attribute, and it is accessible in runtime. That is the main differentiator. Okay, so remember these main points. Now the next question is, what is the difference between break, continue and pass? So the break statement path terminates the loop, and the control will come out of it, will come out of the loop only. So this is an example. Okay, for I in range 10, if I is equal to 5, break. If we write break, it will come out only, it will come automatically out. So the output will be 0, 1, 2, 3, 4, and then when it will come out, done will be printed. So done is over here. So break means it will just come out of the loop. Okay, but when you write continue, it will not come out of the loop, but it will go to the next iteration. That is the difference between break and continue. So the continue statement continues the loop to next iteration. When we call continue statement in loop, it will skip the part where condition is true. So if you can see, I%2 equal to 0, then continue. So it will go to the next iteration. So whenever it is whenever this goes to, it will go ahead, it will go ahead to the next iteration. So 1, 3, 5, 7, 9 will be printed. And what does pass do? Pass does actually nothing. So pass is used wherever you don't want to write any code and you have nothing to write, and so that you do not get error, we write pass over, but pass does nothing. Okay, so pass in Python function acts as a placeholder. It avoids getting error in the code when empty function is run. So if I write if I%3 is equal to 0 and I don't want to do anything, okay, so I will simply write pass over here, so that it goes to the next part. So pass will do nothing, but just to avoid error, because if you do not write anything, it will throw error. So you write pass. Okay, so that is the difference. So the next question is, what are negative indexes and why are they used? So we all know what is indexing. So if this is a list, mango, papaya, cherry and banana, this will have index 0, this will have index 1, this will have index 2, and this will have index 3. But Python also supports negative indexes. So this will have index -1, this will have -2, this will have -3, -4. So if you want to access a value in a list in the reverse way, you can use negative indexes. So this is why negative indexes are used. So they can be used to reverse a number or string without using other functions. So the next question is, what are lambda functions in Python? So lambda is an anonymous function. So in lambda we can take any number of arguments but can perform only one expression. So lambda, so we declare a lambda function like this: a is equal to lambda x colon x into 2, this basically means x square. So x raised to 2. So this means the parameters that you're passing, okay, and this is the expression of the function. So you can have as many arguments, okay, as many arguments you want. So as you can see in this example, we send 3 arguments, a, b and c. So you can send as many arguments you want to send, but the expression will be only one expression can be there in a lambda function. So lambda function just simplifies function writing. So whenever you have a very small function which does a very small task, you can use lambda function like this. So you do not have to write 3-4 lines to declare a function. This will make it easier, and mostly we use lambda functions inside another function. So in another function we'll use lambda so that code is simplified even more. So lambda is an anonymous function. It can take as many arguments, but only one expression it can have. So yeah, so if you want to see an example, print a and 6. So a is this lambda function, and if you are sending 6, so 6 raised to 2, 6 square, so 36 will be the output, and in this case the output will be 6. Okay, in this case, this one, in this case we are sending 1, 2, 3, and the output is 1 plus 2 plus 3, so 6. So this is the output. Okay, now the next question is, what is slicing? So slicing enables accessing parts of sequences like strings, tuples and lists. So if you have a string like this, hello world, and if you want a part of it, then we use slicing. So the syntax of slicing is something like this. There are 2 colons. This one, the first one will specify the starting index. This will specify the last index till which index you want the output, but this is not included. And the third is step. So by default the step is 1, but if you want 2 or 3 you can change it. Step means how much interval you want between the output. So if I write 0 colon 3 means from 0, 1, 2, 3 is not included. So HEL will be the output. So as you can see, the output is HEL. So slicing helps in giving us part of these strings, tuples and lists. So same can happen for list and all. So that is slicing. Question number 11 is, what is self in Python? So question number 11 and 12 I'm going to do together. So what is self and what is init? Okay. So first let's talk about self. So self in Python is a reference to the current instance of class. So whenever we are declaring a class, and self will point towards the current instance of class. So when we define any method in class, we define self parameter in each case as it is used to access variable that belongs to the class. The first argument of every class method, including in it, is always a reference to the current instance of the class. So whenever you are creating a method, the first argument in it will always be reference to the current instance. Okay, so by default any method you will declare, no, the first argument will always be the current instance. So first argument will always be self, but by convention this argument is always named self. You can actually name it anything, but conventionally everyone uses self, so you should also use that. So self refers to the newly created object. In other class method, it refers to the instance whose method was called. So whenever a method is created, the argument is self. Is the current instance of the class, which is generally named self only. So using self keyword, we can access attribute and methods of class. So yeah, that is self. So if you want to understand what is self, self is the current instance of a class. It just points to the current instance of class. That's it. And you can see the example. I'll show you the example, then it will be more clear. So what is init? So init is like a constructor, and it gets called when we create a new instance of a class. So how it's in Java and C++, whenever you whenever you create an object, a constructor is called to create an instance. Okay, so like that in Python we have init. So it is init. So it is like a constructor, and it gets called when we create a new instance of class. So task of the constructor is to initialize. So it is used to initialize values. So init means initializing. So it initializes values to data members of class when object is created. Let's see this example. So we have a class person, and then we have def init function, whose first argument is self. As I already said that every method will have um, first argument is self, and the second is age. So self dot age is age. So this is like a constructor. This is used for initializing. So every time this is used to initialize an object. Then next is a very normal function, first function, and it has self as an argument. Then that will print hello, my age is self dot age. So what is happening? So suppose we declare a variable p, and we are calling this class person, and we are passing 23. So whenever we are passing 23, p is equal to person 23, first this init method will get executed, because we are creating an object, so it has to be initialized. So here it will go. So self dot age is equal to 23. So 23 is passed, so age will become 23 for this object. Okay, for p object. Now p dot first name. Now p dot first, sorry, not first name, this has to be for a first fun. Okay, so yeah, just this is a mistake. But when we are calling this function, we are passing this object p. So p will be passed, and then if we write, then it will print hello, my age is this object's age. So p had what object? 23. So output will be hello, my age is 23. So this is init function. Now 13th question is the difference between array, list and tuple. So this is a very important question. So basic difference is array is mutable, list is also mutable, but tuple is not mutable. So you cannot change values inside a tuple. So array, list and tuple, all the three are ordered collection of items. So this will always be 0, this will always be 1, this will be 2. So it's always ordered, this like 0, 1, 2, 3. Okay, so ordered collection of items. Arrays can store only similar data types. So array will only store one single data type. List can store more than one data type. You can store numbers and all also. Tuple can store more than one data type also. And list is created like this with square brackets, and tuple is created with circular brackets. And this is how array is created. Okay. Now question number 14 is, what is the difference between star args, args and kwargs, keyworded arguments. So this is arguments, this is keyworded arguments, non-keyworded arguments, keyworded arguments. So in Python we can pass a variable number of arguments to a function using special symbols. So as we all know, arguments are passed in functions, but sometimes we don't know the number of arguments we want to pass in a function. That is when we use these arguments. Non-keyworded and keyworded arguments. So this stands for non-keyworded, this stands for keyworded. So we use star as a function's argument when we are not sure about the number of arguments we should pass in a function, as I already said. And star keyworded arguments is used to pass a keyworded variable length argument list. A keyword argument is where you provide a name to the variable as you pass it. So key value pair sort of is sent in this type. So let's see an example to understand better. So this is a function definition, def fun1, and we are declaring it like this. So we are adding star over here, and this is the variable. So when we are calling this function, we can write fun1 and welcome to crack concept. So we are sending 3 variables, but if the star was not there, then it will give error. But star is there, hence we can send variable number of arguments. So we could send 3 arguments over here because star was over here. Okay. So and hence the output is welcome to crack concept. And over here, key value pairs can be sent. Okay. So here I have written a keyword argument is where you provide a name to the variable as you pass it into a function. So we are also providing a name. So first is equal to welcome, second is equal to true, last is equal to crack concepts. So again here star 2 times is written over here, and we are passing this function. So what will be the output? First colon welcome, second colon to, last colon crack concept. So keyworded arguments means you are associating name to every variable that you're sending. So whenever you do not know the number of arguments you want to pass in a function, we use these special symbols star and double star. So yeah, with this we end this video, and I really hope you all like this video, and if this video helped you guys in any way, do consider subscribing to the channel. And also there are other videos in the Python playlist. Do watch it. It will help you in your interview preparation. So yeah, that's it. Goodbye.